Hey Learning Hub fans, ever wondered how your phone seemingly magically predicts what you're going to type next? Or how it translates languages almost instantly? Well, the secret sauce is often a type of neural network called a recurrent neural network or RNN. But before we dive deep, here's a fun question for you. What do a forgetful goldfish and a standard neural networks have in common? Think about it. We'll circle back to the answer later. Welcome to Learning Hub, where we take complicated tech stuff and make it, less complicated. Today, we're tackling recurrent neural networks. Now, you might be thinking, neural networks? Sounds scary, right? But trust me, by the end of this video, you'll be chatting about RNNs at your next water cooler conversation. Simply, neural networks are algorithms used to identify underlying relationships in a set of data that mimics the way the human brain operates. RNN are an evolution of feed-forward neural networks which takes sequential data as input. Think of a regular feed-forward neural network like a one-way street. Information flows in one direction, input to output. That's great for many tasks, but what if the order of the information matters? Like, in a sentence, the meaning of not completely changes the sentiment, right? This is where RNNs comes to the rescue. They have a memory, a loop that allows information to persist. Basically, an RNN takes in an input and the previous hidden state, that's the memory, to make a prediction. We'll break down this architecture. Imagine unrolling the RNN through time. At each time step t, the RNN receives an input xt, combines it with the previous hidden state ht-1, and produces a new hidden state ht and an output yt. Don't panic at the sight of the equations. U, V, and W are just weight matrices that the network learns during training. Tan h is an activation function that squashes the value between -1 and 1, preventing them from exploding. The hidden state ht is like the RNN's memory. It captures information about what the network has seen so far. And the output yt is the prediction at that specific time step. Now let's go to the exciting part. Where are RNNs actually used? Well, they're everywhere. Consider generating text. Give an RNN a seed sentence and it can generate coherent text that sounds surprisingly human. Machine translation is another big game. RNN can learn to map sequences of words in one language to sequences of words in other. Other applications include speech recognition, which means converting audio to text, sentiment analysis, determining the emotions behind text, and even video captioning, meaning automatically generating descriptions for videos. Now, it's not all sunshine and rainbows. Vanilla RNNs have a pesky problem called the vanishing gradient. As the network gets deeper, meaning the sequences get longer, the gradient or the signal that is used to update the weights can become very small, making it difficult for the network to learn long-range dependencies. Imagine trying to whisper a secret to someone across a long room. By the time the message reaches them, it's barely audible. That's kind of what's happening with the gradient in a vanilla RNN. But fear not. Smart people have come up with solutions to the vanishing gradient problem. The most popular ones are LSTMs, long short-term memory networks, and GRUs, that is, gated recurrent units. LSTMs and GRUs uses gate to control the flow of information, allowing them to selectively remember or forget information over long sequences. Think of them as having small values that regulate the flow of the memory. LSTMs are slightly more complex with 3 gates: input, forget, and output. GRUs are a simplified version with 2 gates: update and reset. But both of them do a great job of capturing long-range dependencies. So, remember that question I asked at the beginning? What do a forgetful goldfish and a standard neural network have in common? Well, they both have short memories, unlike LSTMs and GRUs, which are the memory champions of the neural network world. And there you have it, a whirlwind tour of recurrent neural networks. I hope you found this video helpful. If you did, please give it a thumbs up and subscribe to Learning Hub for more explainer videos like this. Leave a comment below suggesting topics you'd like us to cover in the future videos. Until next time, keep learning.